Okay, hello everyone. My name is Dr. Nagaraju, working as assistant professor in the Department of CSE and ML in the Institute of Aeronautical Engineering, Hyderabad. So today we are going to study means we are going to learn the continuation of our Prolog fundamentals. So we can say that I can say that this is the third session what we are going to conduct about related to this Prolog fundamentals. So I sincerely request if you miss that two sessions, kindly watch them and come back here. Why? Because it is completely a continuation, and the explanation is also going to be in that particular sequence only. Okay, so let us move into the today's things what we are going to study. The topics we are going to cover. The topics we are going to cover in this session is one is called as the matching. What we know that which is the most common operation that we perform in any of the programming languages. But here we are going to see the matching in terms of Prolog programming, and we are not going to cover any other traditional programming languages in this case. And we are going to see a lot of examples about this matching and how we are going to learn how this matching is going to be differ from atoms, differ from variables, differ from classes, and differ from complex statements like that. And later on we are going to see the different kinds of the meanings. Means if you take any of the Prolog program, each and every program is going to have different kinds of meanings. Different kinds in the sense there are specifically speaking, there are only two main important ways how we can understand the meaning of a Prolog program. So one is called as declarative and another one is called as a procedural. So in this during our sessions, first after completing this matching concept, we will try to see the different kinds of meanings like declarative and propositional in the Prolog programs, and we are going to see how these two meanings are going to be differ to each other. Okay, so let us directly move into the concept. First we talk about the matching. So the most important operation, and as I also have said that which is the most common operation that we perform in the programming languages. So even we can say sometimes this matching is related with the concept of initialization. Means whenever in the traditional programming languages or in any of the programming languages, whenever we are trying to initialize some values to a particular variable, in that case also we can go for the looking of this matching. Means we can see whether these two values are two numbers or two atoms are matching together or not. So that's why what happens, the most common operation in any of the programming languages, it will be considered it is the matching. So matching alone can produce some interesting computations. So we can say in traditional programming languages, matching in the point of matching, we are not going to concentrate more. Just we see whether both are identical or not, just by using a symbol called as equal symbol. Just means during the time of comparison, we are going to see whether two values are equal to each other or not, whether two strings are equal to each other or not. But when it comes to Prolog programming, we are going to see many different and most interesting things that are linked with the matching concept. So whatever those interesting concepts are there, that we are going to see in this particular session. So that's why I am saying that matching alone itself is not it is going to produce a lot of interesting concepts to us. So what that interesting concepts we will try to see now, and before that let us try to understand what this matching is actually. So the very important word and the most common word that we used while talking about this matching is identical. Means matching in the sense doing some kind of comparison, right? A comparison, and then we are going to come to know that. Means we are going to see whether after performing the comparison of two values or two numbers or two strings, whether both are same or not. Okay, so both are same in the sense it can be both are same in terms of values, or both are representing to one particular thing or not. So like that we are going to do certain kind of comparison. So when you do comparison for understanding whether those two values are matching or not, so first of all we need to see whether they are identical to each other or not. So that is the first primary duty we need to look into it. And then after, the variables in both terms can be instantiated to objects in such a way that after substitution of the variables by these objects, the terms become identical. Right? So I will take one simple example and I will make you understand this statement very clearly. So we can say that x is one particular variable, and I can take one more value which is called as some India. So we know that these are the two terms. Means according to Prolog, we call them these two things as Prolog. So here X is one term and India is another term. So when it is a concept of matching, we are going to do the comparison of the two terms in Prolog. So here I am doing comparison of X and India in this case. So as we know that X and India will not be same, means will not be identical. So we cannot say that we can say that the matching is unsuccessful and we are going to get the answer as false. Okay, but this same things means whenever you take these kind of terms, right, whenever you do the substitution of those variables, then we can say that these two are identical. So when it is going to become identical means whenever I assign the value of India to X, then we can say that here X and India are identical. So this kind of variation that we are going to see in the traditional programming languages and in the Prolog. So I am repeating the statement once again. You see, X and India are two different terms. They are considered as two different terms. When we go for the matching concept, whenever we do the matching of these two values, it is very clear that these two are not same. Means these two terms are not same. So means whenever you perform the matching operation on these two terms, the answer you are going to get is false. But these things can be integrated together. I mean, things can be integrated together by doing this instantiation. So how I am doing instantiation means I am initializing the India to X. I am initializing the term India to X. In this case, what happens? These two, whenever we perform the matching in between these two, we are going to get the result as true. Okay, so the second statement is talking all about the same thing. Means when it is the concept of matching, means when you are writing the programs to look for the matching of different terms, first you need to say whether they are identical to each other or not. Sometimes what happens, the individual terms may not be identical to each other, but when you perform the instantiation, then automatically they are going to be matched, means they are going to be identical, and we can say that in that particular case the match is successful. Let us try to understand the basic idea of matching. So we can say that the two terms match when we can say that if they are equal. Means in the matching concept, if any of the two terms are matching together, then we can say that they are equal. Similarly, two terms match when they can contain variables that can be instantiated in such a way that the resulting terms are equal. So just now we have seen an example of x equal to India. So in this case also we can say that those two are identical to each other. So what does it mean? Right? So what this explanation is telling all about. For example, if you see the terms here, what happened? India and India. These two are the terms. So we know that whenever we do the matching of these two terms, then the answer we are going to get is true. Why? Because India and India are the same atoms. Okay, in the Prolog programming, if I say atom, that means that it is represented by using some alphabets. Means A can be an atom, and also I can be an atom, and India is also can be an atom. So in this case, what happened? In the first case, we are trying to compare the terms India and India. So as those two are the same atoms, and we can say that the match is successful in this case. Means these two are equal. And in the similar way, we can do the comparison of two different values also. So here we are doing the comparison, means matching of 42 and 42. So as 42 and 42 are the same numbers, then here also we can say that the match is successful. The match is successful, and at the same time we can say that term 42 and term 42 is both are identical. Okay, so let us try to take one more example, x and x. So here what happened? X and x also going to match. Right? Why? Because they are the same variables. Means x and x are pointing to the same variable. So when you do the comparison of x with the x, then the answer we are going to get is true. Okay, so why I am telling this true and false means we know that most of the cases the outputs of the Prolog programs are either it can be true or false. Okay, so at the same time we are doing the comparison of these kind of things, which are called as the complex terms. Okay, what this complex term is means generally this complex term is going to frame with a syntax like a relation followed by some kind of object or objects. We can take object or objects. So in this case, what happened? Country is going to become a relation, and India is going to be some value or an object or a term we can take, no problem. Okay, so here whenever we do the comparison of country and India, then definitely those are going to match. But what kind of comparison we have done here? The comparison is nothing but the complex term comparison. As these two complex terms, means these are two complex terms, right, which are represented in this particular form, right, they are identical to each other. Why? Because the relations, both the relations are matching, as well as the values present inside the relation or the object present inside the relation are also matching. So in this case, we can clearly say that some kind of unification process is going to occur before doing while doing this matching. Okay, so that will be there in when you are doing the comparison of the complex terms. Now try to observe this particular thing. So here this is a small c. Okay, so country of India and country of Sri Lanka. So in this particular case also, this is also treated as a complex term itself. These two are treated as a complex terms itself. So when you do the comparison of these complex terms, means when you are trying to identify whether these two complex terms are identical or not, matching to each other or not, then just now I said that some kind of unification process is going to occur here. So in this unification process, the relation names are going to match. So one of the unification rule, we know that there are 3 unification rules, and in that the first unification rule is the relation should match to each other, and the second is the number of arguments present in the relation should match to each other, and the third one is there should be an exact arguments. Means if I take x in the database and in the question also I should represent x itself. Okay, so these are the 3 unification rules. So whenever you are doing a comparison of these complex terms, these 3 unification rules are going to be applied in these two on these two terms to say whether they are identical or not. So in this case, what happens? The first unification rule, that is the 2 relations are same. So this rule is matching here. So there is no problem. When it comes to the second one, the number of arguments present in this should be equal to this. Here what happened in the first complex term, the number of arguments are 1, and here also the number of arguments are 1. Means 2 unification rules are satisfied in this case. Come to the third one. The exact argument, means whatever the argument you have taken here, the same thing, the argument should be here. But what happened in this case, here we have taken the argument as India, but here we have taken the argument as Sri Lanka. So we can clearly say that the third unification rule is not matching. Okay, first, second unification rules are matched, but the third one is not matching. Even when one rule is not matched, we cannot say that the result we are going to get for this particular statement is true. So in this case, what happens? The matching is going to get failed, and the result we are going to get is false. So like this, we are going to do the comparison. So comparison you can make, means the matching you can perform on different atoms, you can perform on different numbers, you can perform on different variables, on complex terms as well. Okay, so that's why at the earlier state I have told that matching is going to generate or going to give a lot of interesting concepts in Prolog. Okay, so these are some of the interesting things what we need to observe. Okay, so these are very, very important. Means we need to come to know about all these things. Why? Because there are a lot of difference between the doing of matching in other programming languages and here. Okay, so let us try to understand more clearly about matching with suitable examples. Let us try to have this particular question. What is that? What about the term India and X? Okay, so this is an example what I have taken at the starting of this session. So when you do the comparison of these two terms individually, so we can say that the match is unsuccessful and you are going to get the result as false. But when you do the instantiation, means when you perform the instantiation, then definitely both are going to become identical. Okay, but here what happened? We are doing the comparison as a simple terms. In this case, what happened is India is going to become atom, and X is going to become a variable. But what happened, even if you take this atom and variable and represented in the form of these complex terms, then what is going to happen? Means even you can do the comparison by taking like this, country of X and country of India. So this is going to match. Okay, so this is going to get match and you are going to get the result as true. When it is going to match means when you do the comparison of these things individually, the answer is going to be false. But when you perform this instantiation, so what is going to happen? It is going to be like this. It is going to be like this. So in this case, as you have performed instantiation, that means we can say that X is identical to India. So that's why after performing the instantiation, if we could able to do this kind of comparison, this kind of matching, then we can say that the result is going to be match. That is, we are going to get the result true. Okay, so this is one of the observation we need to look into it. And let us try to take some of the examples. So I'm trying to increase the complexity of matching here. So we have taken a complex term. This is also a complex term. Why? Because it is represented in the form of a relation and some list of arguments. So here the list of arguments are D, M and 1983. So we can say that D and M, these two are, we can say as we have represented them as X, just like X, we can say that these two are variables. So D and M are representing some variables, and the other argument means the third argument in this complex term is representing the number. Okay, so the same kind of complex term we are taking one more, which is called as here date. In this we have represented D1, May, Y1. Okay, so as I said just now that if you do the individual comparison of these two things, then the answer will be definitely always false. They are always false. So when we can expect the result as match, means when can we expect the result as true, means when you perform the instantiation. So that's why we are saying that when D is instantiated to D1, and when M is instantiated to May, and when Y1 is instantiated to 1983, then only the result we are going to get is the match. Otherwise we can say match successful. And whenever you start asking questions to this Prolog database, the answer you are going to get is true. Okay, so like this also you can do the instantiation, means individually one after other you can do the instantiation, or otherwise you can do the instantiation all together also. Okay, so we can say that this instantiation is more compactly written in the familiar form in which the Prolog outputs results. Okay, so for example, you see in the database you have represented this kind of complex term in the database, but when you are asking the question, so what happened? This kind of representation you have taken. So the answer is going to be true when you perform the instantiation of these two, right? Otherwise the answer will be always false. Okay, so we will try to take one more example. The terms, what is that? Date of DM 1983, 3 parameters, and date of D1, M1 and 1444 are not going to match. So why they are not going to match means this can be instantiated to D1, right? N can be instantiated to M1. Why? Because these two are variables and we are doing the instantiation. But when it comes to 1983 is a number. It is a number. So a number cannot be instantiated with the other number. Okay, first of all, we know a number cannot be instantiated to another number, and also these two numbers are not same. 1983 is not at all same with 1444. So in this case, what happened? Even though this DM can be matched with D1 and DM1 after doing the instantiation, but it is not possible with the case 1983 and 1411. So we say that the match is unsuccessful and the answer we are going to get is false. Okay, so similar to that one, you can do the comparison of these things also, right? You can type these kind of things in the Prolog and you can see what kind of results that are coming. In this case, what happened? All are taken as capital letters. So what does it mean? These three are variables. So we are trying to do comparison or matching of these variables with these three. So here, whenever I write this small y, this is not treated as a variable, but it is treated as some kind of value. So you try to do practice of these kind of things, and you try to observe how the Prolog is going to give the answers when you perform the matching or comparison of these two kinds of things. Okay. right? So that is all about the matching. I hope you understood how that matching can be performed. And once it is done, let us try to move into the meaning of a program. So it is very, very important to understand the meaning of a program. Why? Because whether we could able to convert our problem statement into Prolog code successfully or not, for that one, we should supposed to understand the meaning of the Prolog statements. Means what the Prolog statements are actually telling all about. Means if you could able to easily understand the statements that present in the Prolog program, then easily we can expect what result we are going to get after executing that program. So in the sense, understanding the meaning of a Prolog program is nothing but some kind of verification, we can say, some kind of verification whether we could have done everything correct or not, and whether we are going to get the expected result or not. So that's why if you could clearly able to understand the meaning of a particular program, even without executing also, you can easily understand what result are going to come. Okay, so that's why understanding the meaning of a program is so important. Why? Because once we get convinced with the program what we have written, then easily we can go for the execution process. Okay, so here as I mentioned, there are two different ways. Means there are two different kinds of meanings that every Prolog program will have. Right, one is called as a declarative meaning, and another one is called as procedural meaning. So let us try to see one by one here. So the meaning of a program has always been to understand the results of the program without knowing exactly how the system actually found the results. Means even if you could able to understand the Prolog program statements, it's not necessary to understand how that Prolog has executed the statements and how it could able to generate this kind of results. Okay, just by seeing the statements also you can easily understand. Right, understanding is nothing but here understanding the meaning of each and every statement that we write in the Prolog programs. So here we can say that therefore makes some kind of sense to distinguish between the two levels of meaning. So meaning is not at one level, right? It is of two different levels. So in simple words, we can say that the declarative meaning is going to talk about what? This kind of explanation we have seen in the session where we talked about declarative procedure, declarative reasoning, and also procedural reasoning. Okay, declarative knowledge and procedural knowledge also we have discussed in that particular case. So whenever it is a declarative meaning, means you are trying to understand the meaning of what. Okay, what statements, right? What statements, what they are going to do, right? Whenever we talk about the procedural meaning, they are going to talk about how. Means how we could able to get the results. Okay, so that's why it's so important to understand what and also to understand how about a particular Prolog program. So let us come to the declarative meaning here. Declarative meaning is concerned only with the relations defined by the program. Means in the Prolog program, what are the different kinds of relations are there, and what that relations are talking about. So this kind of meaning are given by the declarative meaning. So the declarative meaning thus determines what will be the output of the program. It is going to just say that what will be the output of the program, but it is not going to explain how that result has been obtained, how the result is obtained. So that's why we are saying that every time this procedural meaning is going to concentrate on a particular word which is called as what. So the procedural meaning, if we talk about the procedural meaning, it is also going to determine how this output is obtained. Okay, so if you want to know what output we are going to get, simply you need to understand the declarative meaning of the program. But if you want to know how the Prolog program, Prolog interpreter is executing the statements and how it has given a particular result, then you should supposed to know, or you should supposed to understand the exact meaning which is called as here the procedural meaning of a program. So we can say that declarative is going to talk about what will be the output of the program, and procedural meaning is going to talk about the how this output has been obtained. So how are the relations actually evaluated by the Prolog system? This is going to be known or understood by understanding the procedural meaning. So if you specifically talk about the declarative meaning, we can say that Prolog programs can be understood in two different ways. That is, just now I told, declaratively and procedurally. but these two are having two different meanings, we can say. So let us try to understand the first class. So what is this first class? P, this symbol, and Q comma R. So we can say that this is not a fact, but this is a, okay, we can say that this is a predicate. This is a predicate, or otherwise this is a rule. This is a predicate or this is a rule. So what this rule is talking all about? So where P, Q and R have the syntax of terms. So if we treat about this statement as terms, so what this term is talking all about? So simply we can say that P is true. This statement is going to explain in this way. P is true. So when it is going to be true when Q and R are true. Okay, so this particular clause is talking all about that one. So P is going to be true. When it is going to be true means when Q and R are true. So means if you want to prove that P is true, before that you have to prove first Q and later on you have to prove that R. Okay, means once you prove that Q is true and later on R is true, then automatically you can able to prove that P is true. So why we are taking this one as and? Because the comma in between these two are going to tell about that one only. Okay, so we can say that whenever you represent this kind of thing, then it is nothing but representing the statements in the form of if then. Okay, so if then means P is going to be true. Okay, P is going to be true means, for that means if you want to prove that P is Q, before that you need to prove Q first. Prove Q is true first. So then later on what happened? Comma is there. So comma is means even you need to prove that R is also true. Okay, so this one we can say it as a conjunction. When it is conjunction, or we can also say that comma is called as a what we can say logical and. Right, it's not a logical and, we can say that simply and we can say, or we can say that logical connective and. According to Prolog, we can say that this is called as a connective and or logical connective and. Logical connective and. So even in simple words you can take even logical and also, but this term will be the best suitable term to that one. Okay, so whenever I represent comma in between the clauses, so you should suppose to prove both, then only you can able to prove that P is also true. And here even the sequence is also matters here. So if what happens if I prove Q R as true first and then later on Q as next, so we cannot clearly say that we are going to prove that P is also true. So that's why even sequence is also we need to follow. Means in order to prove that P is true, first of all, you need to prove this Q is true. Then later on, means once you prove that Q is true, then only you have to go for R. R is also true, like that. Okay, so this is the way how we need to understand the meaning of these representations. And some alternatives also there. So already these alternatives I have explained to you. What is that? P is true if Q and R are true. So even we can read this statement in a different way also. From Q and R follows P. Okay, so one statement is telling that P is true if Q and R are true. Or otherwise you can read that statement as from Q and R follows P. Okay. So let us try to formalize the declarative meaning here. So there are two alternative procedural readings for this class. Two alternative. One is, you see, to solve P, first solve the subproblem. Okay, sorry, this is Q. Okay, first solve the subproblem Q and then solve the subproblem R. Or otherwise we can say that to satisfy P, first you satisfy Q and then R. Okay, this already I explained now. So you try to understand the differences between these two. Okay, so not only define the logical relationships between the head and the clause, but also the goals in the body and also the order in which the goals are proceeded. That's why I have repeatedly used that particular statement. Even the order of proving is also very, very important. If Q is Q present first and later on R present first, your procedure should be satisfy Q first, then satisfy R. So if it is R comma Q, even if the statement is like this, then you need to prove R first, then after you need to prove Q. Okay, so that is a difference that present in this one. So the declarative meaning of programs determines whether a given goal is true, whether the given goal is true. So if so what values of variables it is true, for what kind of variables it is true, that we are going to see. And here there is no need to introduce the concept of instance of a class. So as we have seen in the matching, right, until and unless you introduce the matching, you are initialization, you cannot able to prove that the matching is successful. But in this particular case, it's not necessary, right? It's not necessary to understand the concept of instantiation when we are talking about some kind of clauses. So what does it mean? An instance of class C is the class C with each of its variables substituted by some other terms. Okay, so a variant of class C is such an instance of the class C where each variable is substituted by other variable. Just now we have seen D, we have substituted with another variable which is called as D1. At the same time, M we have substituted with M1. Okay, like this it is going to be. Let us try to understand some of the examples. So what is that? Has a child. So X has a child. This is the thing what we need to prove. So in order to prove this one, first of all we need to prove this. What is that? We need to prove this parent X comma Y. So how we need to understand this? Means X is a parent of Y. X is a parent of Y. So this kind of explanations we have seen in the earlier sessions. Okay, so if you could able to prove that X is the parent of Y, then automatically we can say that X has a child. So this one class we can represent in two different ways again. So what is that? Just now we said that substitution of the variables with the another variables. Okay, substitution of one term with the another term. So in this case, what happened? Instead of X comma Y, we have taken it as parent A comma B. So there is no change in the meaning, right? Meaning is going to be the same. What is that? A is a parent of B. But in the earlier case, it is X is a parent of Y. So we can say that these two statements are general statements. General statements in the sense you can replace these variables, or you can instantiate these variables with any of the values. There will be no problem in this case. Means you can instantiate with any of the atoms. There is no problem. But only the thing is we are going to see the different kinds of variations of this class. Means even if in place of X comma Y, if you take A comma B, there is no change in the meaning. And similar to that one, you observe the second variation. In place of X comma Y, A comma B, we have taken as X1 comma X2. The meaning will be same. Right? What is that? X1 is the parent of X2. So if you could able to prove that X1 is the parent of X2, then obviously we can prove that X1 is having a child. Okay, so let us talk about the instances of this particular class. What is that? Has a child. See, initially we worked with, means all these examples are talking talking in terms of the variables. But when it comes to here, we are talking about the instances, right? Instances is nothing but some kind of values, right? Some kind of values. You try to observe. Parent Peter comma Z. So parent is the relation here, and Peter and Z are the two arguments. So Peter is in the form of value and Z is in the form of a variable, right? But still there is no change in the meaning. What is that? Peter is the parent of Z, but who is Z here? You can replace that Z, means you can instantiate that Z with any of the value. Means in this case also, if you could able to prove that Peter is the parent of Z, then obviously we can prove that Peter has a child. Okay, so we can take the combination like this. Means one argument as value and another argument with variable. In the similar case, even you can take all the variables only, or otherwise you can take all the values only. Means directly doing the comparison of values. But only the thing is, right, once you have to prove that the other side of this if is you need to prove first. Then later on you have to go to this particular corner. Means has a child, Barry has a child, means in order to prove this one, first of all I need to prove this, then later on I can go for particular this one. So we can say that it is just like from left hand side to the right hand side. Sorry, it is from right hand sides to left hand side. Okay, it will be like this. So even when we are trying to understand the meaning of the Prolog program, even you need to consider about this conjunction and distinctions also. Because just now we have seen one example, that is P if Q comma R. So in this case, what we have explained, that in order to prove P, you should suppose to prove Q and R. So this is called as logical connective and this is nothing but here the and here. Both need to be true, then only we can prove that P is also true. But sometimes what happens in the general example, in the regular examples, even you can see the distinction kind of things also. So let us try to understand what happens if means how to understand the meaning of the statement when you make use of these distinctions. Means when your statement is having this distinction. So a comma between goals thus denote the conjunction of the goals. So that is, they must be true. Both must be true. But in some cases what happens, it's not necessary to be that both need to be true. Means if you want to prove that P is true, it's not necessary that you need to prove Q and 2 to be true. So even what happens, even if Q are false or true, R is false, then also you can able to prove that P is true. So when it can happen, means whenever you use this distinction. Whenever you use distinction. That's why we say that Prolog is also going to accept distinction along with the conjunction. That is, any one of the goal in the distinction must be true. Okay, so we can represent the statement like this. You see, true or false. In this true or false also you can prove that P is true. Right? In the similar case, even you can take like this, false or true. In this case also you can prove that P is true. So it's not, that's why we are telling that it's not necessary that both should be true. Just we see this logical or operator in the other programming languages in a similar way. But only the thing is how we are representing that disjunction is the matter here. So in place of comma, we are going to see the semicolon. Okay, we will try to see some examples and we will understand how this distinction can be used. So let us try to see the first example. What is that? P if Q semicolon, right, R. So what does it mean? P is true, means when it is going to be true, means when the P is going to be true, means if Q is true or R is true. So it's not necessary that both Q and R should be true. So we can simply write in the another way also like this. Okay, Q and R separate. But still there is no problem. But sometimes what happens, even there will be some little bit of complex predicate you are going to get, complex rules. What is that? The common binds stronger than the semicolon. How comma is going to bind stronger than the semicolon? How it will be? You see, P means if you want to prove that P is true, then first of all what you need to do? You need to prove both Q and R are true, and you need to prove S, T, U are also true. Why? Because there are comma in between. So later on, for example, think that you have proved these two are true. Then the first portion is going to get the result as true. And later on, you have proved these two things also true. So what is there in between? Semicolon. Semicolon indicates that it is R. Okay, so it's not necessary that both should be true in order to prove that Q is true. But in this case, it is not like that. But what happened here? The same statement, it is been splitted into two different statements. What is that? Means if you want to prove this true, first of all, you need to prove S, T and U also are true. Later on, so individually you have to prove that Q and R also true. Okay, so you try to understand the meaning in this one. Whenever you are looking for this particular portion, you should suppose to prove both Q and R are true. But when it comes to, for example, here also you need to prove that S, T and U are also true. But when it comes to the result of this QR and result of STU, it's not necessary that both should be true. Then also, means even if any one of the portion is giving the result as false, then also you can prove that P is true. Okay, so this is how we need to understand these kind of statements in the prologue. Coming to the procedural meaning. So procedural meaning, just now we told that it is going to talk about how, means how the prologue interpreter or how the prologue system has executed the prologue statements and how that result has been obtained. Okay, so to answer a question means to try to satisfy a list of goals. So there will be some list of goals will be there. Whenever that list of goals are satisfied, then we can say that we have given the answer to that particular question. So why we talk about this particular word means we know that in prologue you can raise questions. Until and unless you raise the questions, you cannot able to execute the statements. In the sense, you could not able to test whether you have designed a very perfect prologue database or not. Okay, so you need to feed the knowledge in the form of a prologue database, and then you should supposed to ask the questions to determine whether you have represented the knowledge in the perfect way or not. So we can say that the procedural meaning of the prologue is a procedure for executing a list of goals. So simply means if you talk about the declarative meaning is going to tell what goals are there. What goals? For example, it can say that goal 1, goal 2, goal 3. Okay, so it is not going to tell that how the procedure means how we are going to execute these 3 goals. That kind of information or that kind of meaning you are not going to get with the declarative meanings. So in order to understand the procedure or the execution process of these goals, you should supposed to understand the procedural meaning of prologue. So we can say that to execute goals is nothing but to satisfy them. Okay, so there is one small diagram which clearly tells about that. Okay, so this is a figure talking about the execution process here. What happened? For execution, 2 things are there. One will be the prologue program and other one is the goals list. So in this case, what happens means whenever you execute the particular program, right, the results can be either success or it can be failure. Means the output can be an indicator of success or it can be an indicator of failure. Sometimes what happens, it is not just true or false represented outputs, but it may be the instantiation of variables. Means the execution process of every program by taking a list of variables can give 2 different kinds of results to us. Either it can be an indicator which is going to tell whether the execution process is success or failed. Means abnormal termination we can say. Or otherwise the other option is the instantiation of a variable. So let us try to talk about the 2 output results here. If it is the success and a failure, that means that it is the indication of S. If the goals are satisfiable, right, means when the goals are satisfied, then the output we are going to get is S, or otherwise we can say true, right, or otherwise while writing we can represent it as T. But what happens when the goals are not satisfied? So in this case, you are going to get the result as no. Okay, so what this S is talking about, that successful termination. But what no is talking about? No is talking about a failure. So an instantiation of variables is only produced in the case of a successful termination. So the second one, instantiation of the variables, right? That can be possible whenever the particular goals mentioned are satisfied. Then only it is possible. Otherwise, we can say that if there is a failure, means when it is a failure, there is no point of any instantiation. Okay, like this you need to understand that 2 different kinds of meanings that every general programming prologue program will have. So in summary, I can say that the declarative meaning is nothing but trying to understand what are the relations, or nothing but what are the goals and what kind of results they are going to produce. But when it comes to procedural knowledge, we are going to see the procedure of executing those goals. Means how those goals are executing, right, and what kind of how it would able to produce the result. Okay, so this is all about the declarative matching, declarative meaning and procedural meaning of a prologue program. And this is a reference what I have used in order to prepare the content. Hope so you understand these 3 concepts, and we will try to meet in the next session with the concept of lists. Till then, thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.